So we will move on and we will still talk about experimenting, and I will invite to the stage Laurens Bekemans, who is also the founder of BC Architects and Studies and Materials, and he will bring out all the different cool stuff he's doing and talking about experimentation and circularity. The floor is yours.
Thank you very much for this lovely introduction. I'm super happy to be here. It's a year since I've been here, and I had an amazing time. I had lovely hosts. I will not get into detail. But before I start, I want to say two things. One, that when I visited the pavilion, I was very disappointed to hear you didn't get the Golden Lion afterwards, because I think it was at the Biennale, it was a really one of the best pavilions, which showed really the potential and the needs that the Biennale has to kind of work around with all this trash. And second, I'm gonna say sorry, I didn't give you a decent title, and I think the introduction to it as experimenting is quite fitting the presentation which I will do, or which I will give, because I think in the airplane, I was scrolling through it to remind me of the things I'm going to talk to you about. And I was really seeing that throughout the course of the projects that I will show, the importance of experimenting in architecture and prototyping architecture is very important today, because we have to create reference projects that inspire and that show what things are possible. And also as architects, we have the responsibility in that way to learn from our own projects, from our own failures, and overcome them. And in our next projects and other projects we do, always build upon this kind of new knowledge that we gather. Because at the end, when we do projects, we gather new information, we work around new things, we try to adapt around new legislations, new norms. We see failures in those norms, and so I think as architects, more and more today, we have to be activistic in that way. And so the importance of experimenting would be a fitting title, I think. So I will enter now the presentation, and indeed BC, so I'm part of this group, let's say. BC today is a hybrid office because it contains three chapters, of which one is BC Architects, which is an architectural practice, doing architecture, having its insurances, and focusing a lot on locally sourced materials or circular approaches on things that today also have been dubbed as bioregional architecture, bioregional approaches. So we have that entity, which has its own legal form. But throughout the course of our existence, two other entities, two other chapters came to be, of one of which is BC Studies, which is an association. It's a different legal form. And BC Studies really focuses on education, workshops. It focuses on sensibilization, on transferring the knowledge that within the practice of BC, within the projects we do, is gathered, is created, and we work with. And so through BC Studies, we make connections with universities, we organize workshops, so that's really the focus. And it's a non-profit organization. Non-profit because it fits the idea of education, something that you're not creating any kind of business plan around. And then the latest one, BC Materials. BC Materials came to be, I think, approximately almost 5 years ago. It's a workers' cooperative. Different legal structure, and BC Materials really focuses a lot on development of materials from excavated earth of construction sites. At least that was the main core where it started with. Today, it goes further and it goes into biosourced materials. It goes into in training of contractors, because all this, I wouldn't say, again, it hasn't been mentioned today, new techniques, but at least these techniques with earth and so on, they have to be in a kind of way also opened up towards contractors in order to have the knowledgeable people to apply things that we as architects are in kind of frontier and pioneering in circularity we wish to kind of be done. And it's three entities, quite a complex structure if you look at accountability to manage all these things. It was never also our idea when we started architecture to say like, okay, let's make the most complicated form of business so that we make a lot of mistakes. But it was something that happened to be, it's something that came to be today as we had a goal, or we had a kind of, or a goal was set by us. And to achieve that goal, we realized that the tools we had today as architects were not sufficient. Therefore, we had to extend in other practices. I'll go over a few key projects, a few milestones, in which each time you see kind of elements coming back in other projects and showing the in lacunas, the missing links that we wanted and we wish to kind of work on. And one of the very first ones, and there we go back to my, when I was young, I'm still young actually, but I have back pain since a few years. But this was a first project that for me, and for many of us at the practice, we entered a different kind of context in which building was something you did with a group of people. It was a project in which we were not the architects, we were the colleagues of a foreman, of a mason. And I think the amount of things that we learned in this project of working more as a group towards, within trust, towards goals was an important thing. This is a project situated in Central Africa. And next to this kind of way of working, I think a very important part of this project was also the first discovery of us, of the material earth, of the excavated earth that came to be from the foundations from this building. And it showed us the importance. We came just from university here. We were quite naive, but it showed us suddenly the importance of understanding the materials we worked with and setting that at the start of our design trajectory rather than at the end. Not start with concepts that were based on design or architectural kind of form, but were based on the characteristics of a material, the understanding of a material, and more specifically here, a bespoke material that we made out of the excavated earth of this project. So this was really kind of a start for us, which jumping 2 years later, we won a competition in Belgium, our first one. It was a bio school, they call it, a kind of extension of schools where children go to study biology and nature. And we applied the things that we had learned from our previous project, which meant that we looked firstly at the resources we had, and Belgium is a very rich clay country. They say we have a brick in our belly, but many other countries have that same issue. And so with the earth, the excavated earth we wanted to build. But of course a different economical context, one in which producing a material on site, a bespoke material, just is almost impossible. Not almost, it is actually impossible, even for such a small project, because we're talking about 300 square meters. And so here came in the first kind of sediments of the idea of organizing workshops in order to at once transfer the knowledge of this kind of materiality, of locally sourced materials and so on, but at the same time produce. In this project, it's consolidated, but at the same time, it became very complicated because we reached the kind of limits of such a thing. Producing 20,000 blocks within a workshop environment is quite to the limits of where are you teaching and where are you really focusing on a deadline. These blocks were then actually, as architects, we produced these blocks, we researched them, produced them, and actually we sold them for a symbolic €1 to the contractor who then worked with it. Another issue was, of course, the fact that bespoke materials, which have no technical sheet, were unworkable or hardly workable by the engineers. So they they weren't able to give the trust to the client, I would say, to kind of say that it would work, because we're using here compressed earth blocks in a load-bearing way with arches. No concrete was used to kind of keep the main structure. And so the idea of prototyping with these materials in order for the engineer to experience the material one-on-one and test it really on-site with prototypes and mock-ups became important. And then we reached another, I mean, we had this possibility of kind of going in depth in materials, going in depth in developing formulas for reusing excavated earth. But our goal was to kind of make sure this would be a much more common practice. But of course, I could hardly imagine architects using a workshop format to build 2,000 square meters of housing. And so here came our next step in order to kind of improve and lower the threshold of these materials. Our next project was not in building, but it was a cooperative. A cooperative which would focus on the excavated earth of Brussels, because Brussels has very rich soil in that way. And so starting from a research which was partly funded by the Brussels region, we developed a cooperative which allowed architects to use these materials within a more protected framework, which they could buy, and we built our own production hall in order to produce these materials. And if you look at the section, and this is the section of Brussels, you notice this kind of purple line, which is rich clay soil that you can discover when you deep down, you go at 8 meters depth, and you have even the yellow, which is very good kind of sand. You have even a neighborhood in Brussels, which is called Sablon, which is referring to the old sand quarry. Sablon means sand in French. But these are actually the quarries we have in the city, and we have clay, we have sand, and we have granulates. And even further, when you look at large-scale construction works, we were able to kind of delve even deeper into the research of these materials, because there was a planned, well, it's still planned, let's see, extension of the metro line in Brussels, which dug quite deep into the crust. And we were able to extend and get funded in order to understand the potential of the earth, which was dug out from the construction of these metro lines, and reuse it in the building of the metro stations themselves. And there was a potential, 100% potential of doing this. But then we come to the next kind of step in the story, or at least in the projects we have, because to the left you can see our production hall, where you can imagine if tons and tons of materials arrive and we have to produce many blocks, it's impossible. And even the blocks that we were selling are quite pricey. We are not within the logic of an industry, we're in the logic of a factory, something in between. So next step in the idea of how to improve this material, this excavated earth, but earth in general, as a kind of democratized material for the many, and not just for large-scale buildings, but for everybody in general. We started to look into the potential of collaborating with existing industries, because if you want to produce more, if you want to produce more to lower the cost, there's an enormous capital you have to invest, but there is already existing the machinery to do so. And so this allowed us today, with a collaboration with concrete industry, which has machined to compressed concrete blocks for the streets, or even with other companies of fired bricks, to use their machinery, hack it, and allow it to produce unfired earth blocks, produced earth mixes. And therefore today we have a kind of catalog of materials, earth materials, based on the excavated sand, excavated clays of the region of Brussels. And it allows you to open an enormous gamma of materials, going from paints to mortars to blocks. And the next step is in developing the legal framework around these materials, because still today there are a few, there are more, there are coming more, but it's still a large work that that we envision to do. We arrive here, I think, with architects who from designing buildings become geologists, researchers, and there's this group of people with this kind of ambition to use more and more this kind of locally sourced materials. At the same time, this kind of knowledge allowed us to use these resources of Brussels in larger scale materials. This is a renovation which finished, partially finished a few months ago. The renovation of the old military school in Brussels. And in this project, which is a renovation, and we try to keep as much as possible of the existing, parts were, which you see here, parts were demounted. And of course, when you're in an urban setting, you don't only have excavated earth, but as we've seen many times before today in the presentations, you have also, of course, the built environment itself, which can give you the potential of using bricks, for example, in this case, of a demounted building, glass, smaller elements. But you can see that today, I feel at least that at the level of components of building, we're there, and it's getting easier and easier. Definitely in Brussels, you have practices such as rotor, which are so important. And the threshold is getting lower and lower to allow to reuse materials from the city. Harder is today, I feel, or at least that's what we experience when you start to reuse materials for structure. There you enter a different level of architecture or a different level of construction in which materials has to, according to regulations, achieve much more higher values. So I think for us, this is a new challenge for the coming years, is how to understand and reuse elements of the city in a structural way. Of course, in this renovation, we also use biosourced materials such as hempcrete. We organized little workshops together with the contractors, and all of these public buildings. So it's always also not, it's always a negotiation, of course, with the client to see how much you can involve the public in such a public building. But I want to finish with this project, and I don't understand the timing. Do I have 27 minutes or? Yeah, I think so. So this is another project which is, again, quite large scale, but what I think is interesting here, which I will explain, is one element of the initial project, how it informed a new one and how it's today developing a new supply chain within a region. This is a project finished 2 years ago, 2023, yeah, almost 2 years ago, a year and a half. It's a renovation of old train station buildings in the south of France, in the city of Arles. Client is the Luma Foundation, quite a financial strong art foundation, and it has a chapter within its foundation which is called Atelier Luma, which focuses on the development of materials from its region, and more specifically the Camargue region. Entering this project, during which we collaborated with Assemble, the same kind of methodology in which we try to understand firstly the region, the materials, the resources, the people that are kind of acting within the bioregion. There's an image not relevant in this case. This is the building in its initial state. And Atelier Luma had already quite a past of researching agricultural waste or agricultural practices in the wetland. One of them was the sunflowers, in which the stems of the sunflowers were left and were a waste from the agriculture. So they had this kind of work identifying potentials of the region. Salt, we have a lot of salt production in the Camargue, which they used then to develop tiles from. Algae, which contains alginite, which is quite interesting in the replacement of clay, for example, for certain plaster, but it functions as a binder, such as cellulose of plants functions. But all this at the level of quite design. When we entered, we introduced other materials which came from our expertise, such as stone dust. When we went to visit quarries in the region, which are limestone quarries, there was a lot of stone dust, which was not valorized in their kind of supply chain. Sand quarries where water was used to sieve the earth dug up in order to get just the sand at a high quality. Clay was a lot present still in this water residue. And the building itself, of course. In the renovations, there were parts that we had to demolish or parts that we had to take away, such as the tiles. And these were always sources of material, sources of construction. The renovation itself is quite easy in a way. We kept all the structural walls. The full building was insulated with rice straw bale. And then we had 3 main spaces, one which was left as it was, as found, to the longitudinal one, which was focused on biofibers in terms of material use, because it was a kind of loud and acoustical important space. And then we had the more square one where we focused on geosourced materials. And again, as today, like what we did at the beginning, it took us months and months to research these things. Today, this goes much faster because we notice that stakeholders are slightly more open to these kind of ways in which a material such as stone dust, we reformulated in a kind of round earth mix, which went through a kind of lab testing format in which the Studiebureau, which is a kind of control office, allowed to development of a protocol. Instead of a technical sheet, it was a technical protocol in order to allow a control during the building site construction, which enabled us to have these kind of large and beautiful white load-bearing rammed earth walls. Again, the construction site was opened to students. These were at certain moments in the construction where it was a bit quieter. And I think, again, this kind of fibers, the importance of them, and the other spaces where we worked a lot, again, with the sunflowers. And so at the end, we had this almost 20 materials that we bespoke developed for this building. I would say 99% not replicable, too expensive, economically not viable for a region, because there was just no clients, no people involved in it. But what the importance of this building was to become a showcase and inspiring people to see like the potential of a bioregion. Because there is so much that can potentially be used and is understood today as a waste or undervalorized in order to build it. But there's one that really kept going today and is now at legal level there's now a supply chain being set up in the Camargue, and that's the rice straw. So we used the rice straw in our building for acoustical panels, but more importantly, we insulated the complete inside with rice straw. Rice straw is a waste material for the rice agriculture in the Camargue because it's not used to fertilize the land. And it had when we started, it had no regulation. We use cereal straw bale. It has a regulation. Rice straw is approximately the same, but it was not regularized yet. And as it was not regularized, it didn't have a existing kind of platform onto which farmers could kind of work with. Another part by using the rice straw I was so shocked on the amount of wood that we had to use in order to insulate the whole building. And so what I think is also interesting, during the construction itself, we changed format. So we organized a workshop together with Harvard University on straw bale construction, and we involved 2 contractors of the region who did that. But we were focused on load-bearing straw bale construction because doing so, we minimized 60% of wood use. And when we were building this, it was COVID, and I don't know, in France, there was no wood anymore. Everything was bought up, and wood became extremely pricey. We had all this ambition of using local wood. We could forget about it, or we could wait a year before building. So we wanted really to minimize the amount of wood. And so together with Harvard, we organized this workshop with the contractors, and we managed to insulate the last part of the building with a load-bearing rice straw bale load-bearing construction. And so after this project, this is the space afterwards. And now I going to go in. So as I mentioned, this project is really showcasing. And I'm personally, and the whole team is very happy to see that the contractors we worked with and the farmers who gave the rice straw bales, they organized themselves in order to promote the use of rice straw bale in the region, and set up a kind of, I don't know the exact expression, but a kind of organization around the riziculture, which would be the rice culture. And we did a project together with them. And this is actually, I took the presentation of the contractors, so there's quite a lot of attention to the project. And I saw their presentation, and I thought I have to use that. Because it really shows also the importance of contractors and their kind of world and communicating what is happening. Because of course, we're all communicating this between architects, and I hope in the future we will use these methodologies and so on. But if you don't have the contractors who are next to you, who are willing to apply, who are aware of these kind of changes, who are willing to take the risk or understand which type of risk they're taking, we're stuck. And so this project, which I go through shortly because now I see the time ticking. So this is the renovation, and this is not linked anymore to the kind of rich Luma Foundation. This is a project for the city of Arles. It's the renovation of an old clinic into student housing. And of course, there's the ambition of keeping the whole clinic as such with its structure, and there's the ambition of utilizing as much as possible of the existing stock of sinks and debris and light installations and so on. Even actually of the exteriors, we're able to kind of reintroduce elements from pathways from the city into the building. But yeah, and before I enter the other part, and so we have this stock of components that we're able to reuse. Next to that, there's a kind of maximization of the use of the existing structure. There's an extension at the back. There was the old chirurgical kind of where they did all the, not the examination, but the cutting. So these spaces were at the back, but of course they were completely almost out of plastic because they were cleaned each day. But we kept the footprint with an extension with the refectory and kitchens. This complete extension is in wood and earth. We had an overproduction of the blocks for the Lot 8 project, so we managed to buy them very cheap from the Luma Foundation. And next to that, we focused on local wood, which for us was after having done Lot 8 and having been kind of cut in our heart by having to use wood that came from much further than the region itself. We really focused on that, and I was surprised how much it took actually to just for 20 beams and columns and using cypress, which is growing in the region, and cedar. It was a whole quite of energy that involved in us convincing, not really the client, but convincing contractors, the sawmill to kind of use these structures and also use them in a wood and on wood kind of connection. And there comes the whole skin. So of course, we all are aware of straw bales having 35, 36 centimeters. So if you imagine the existing structure of the hospital, which was already quite small, it was impossible to insulate from the inside. So together with the contractors, we really kind of went, oh, there's something else. Oh, this comes after. So we decided to really insulate the whole building from the exterior. In France, there's really a very well documented kind of book on insulating with straw bale. So it's, as such, it's nothing new, but it has never really been done at this level or at this scale. And for the Pauli project, we had to insulate in total, I think, with 30 tons of rice straw. And when you looked at the region, which is unvalorized, so we have a whole amount of straw being produced in the region in Valensole, 540, of which a lot of blé. But if you look at the Camargue, there's 27,000 tons of undervalorized rice straw, which actually means thousands of these projects for the region a year, which is enormous. And we all know, of course, the characteristics of straw bale, and they're the same ones with rice straw bales. But of course, again, they have this kind of very thick, well, they have this enormous thickness. So the whole exterior was insulated. And what is interesting, and that's why there's an interest in this project, because this is 70s, 80s concrete block construction, and it is exactly the same as almost 70% of all the social housing the south of France has to insulate in the coming 20 years. And therefore, this kind of project allows us to check the application of rice straw insulation from the outside. And as a cover, and that's what you had seen just before, we're actually using the broken roof tiles, which we crush, together with quicklime, which is not the trascalk that we all know that is used also in concrete, but it's a less processed lime. And by using the broken roof tiles, it's a Venetian coccio-pesto, because the roof tiles, as they're burned clay, they're quite porous, and they create a kind of strengthening effect of the lime plaster itself, which closes quite well the, here we go, technical, sorry, which closes quite well the straw bales and protect the straw bales from rain. And so when we go a bit further, I love this image, how the contractor explained how they kind of work in the construction of a self-load bearing rice straw, which is basically you minimize the vertical wooden elements, you create a shelving technique, and you have ring beams kind of compressing the straw bales and dividing the load accordingly. So like that, we minimized approximately 60%. Another interesting element here, these are things that we had to do in order to see if the straw bales could be slightly attached to the concrete wall. These are all tools that exist, but not in this way. These are the straps that are used for the construction. Maybe this goes slightly more technical. I think what I maybe more want to show you is at the end another part in this building, which is the backside. So another issue insulating with these 35 centimeter thick rice straw bales is, of course, the loss of space. And so, for example, for the terracing, it was impossible. But we were surprised to see that there's development also in the world of contractors and producers of materials. So I think it is very clear how a company like Copano, which is today there since 3 years, they developed actually a tool, a machine. So there's in that way also an understanding the lack of certain type of machines to produce from locally sourced materials, ready-made materials for construction. This is actually basically a huge I think, 3-meter wide sewing machine in which the rice straw is put through, and it actually stitches the whole thing, and then you can easily cut. And it's a game changer for the construction industry. It's these type of companies. So like I'm a big fan of this Copano because it's this type of companies which are wishing to go a step further, that have received subventions, of course, from the French state in order to research and come up with ways of using these materials such as these in the construction sector. And so it's similar to what BC Materials was trying to do in a kind of way, to lower the threshold for architects, for constructors, for entrepreneurs to use these materials in order to put them much more in front of the existing kind of lobby that we had in the past years of concrete and so on. Here it shows just the importance of distance. So we are lucky that the factory of Copano is close by the region, because when you exceed 500 kilometers, it already starts to, the CO2 footprint starts to go in negative almost. And yeah, they only have still to change the plastic fibers, but they're 99%. That's kind of good. And yeah. And so what is important at the end, and I want to maybe finish with this slide because I see I'm over time, is the importance of these projects. Maybe I end here. The Pauli Clinic and the Lot 8 Clinic, they're all used in order to develop the new regulations for rice straw as a load-bearing technique. Because by having this kind of project, reference projects which go a few steps further, they allow also governments, they allow contractors, they allow the whole construction culture to see the proof, or to see the proof that these things can work. We can see, of course, the things that didn't. But you can also determine from these projects the qualities and the potential and the quantity we have in order to tackle certain challenges, such as the upcoming renovation of a whole, of all the, for example, in the south of France, of the whole kind of social housing that is there. So yeah, that's a bit a wrap up of what I wanted to share to you today. Thank you.
That was so interesting. I forgot I'm the moderator, just sitting there enjoying. But thank you. It was really inspiring. I know we have some people from local clay business, and they were also interested in your presentation. Definitely. Tell me, you started off with a very stoic approach that you learn from mistakes. What has been your biggest mistake during this career?
Oh. Yeah, I'm thinking. I think we made a lot of little mistakes. If we made one very big mistake, I don't think I would be standing here. But I think what we always try to do in each project is take a small risk. Each time a small risk, more and more, kind of controlled risk, in which we are aware of.
To push it further, always.
Yeah. We have had there was one wall that once collapsed, which was 15 meters high. Luckily, nobody was there. But other than that, I think we have been quite well in taking calculated risks each time, and don't go too far either, because of course, I think it's important that you do it step by step and don't miss any. Or a few you can, but
and you started from a very local scale, then going to the workshop phase, then even scaling up, having a catalog of objects, and then going to even renovating bigger buildings with straw bale. What's your next dream? What's the even higher scale?
Christian, did you present StatSat? No. I think our next, of course, if you would ask anybody else, maybe of BC, you would get each time another answer. I think now for us, or again for me, a very interesting step is the kind of internal organization of our office, of our practices.
Okay.
And I think how can we also within work in a sustainable way? We have been doing projects, or at least trying to do projects in a circular and a sustainable way, pushing each time a bit further. But how can we look now also internally, and how can we do this within also a kind of sustainable way of being a practice with the people we work with and so on? I think that, I mean, me personally, that's an important one. And one of the outcomes of this is a project that Christian has been Steunen has been supporting a lot, and that we've been now doing together with a contractor, a Brussels-based contractor, and it's the kind of building of our call them headquarters of premises within the city of Brussels, quite central. In order for them, a contractor, have a storage place in the city, which allows them to, in a much more efficient way, be able to do reuse in the city. Yeah. Because I think Future Build explained as well the importance of storage spaces in a city to allow circular construction. And so, yeah, this kind of synergy with even many more actors of the circular economy in Brussels, being together, having a place to share these kind of experiences and so on. So
cool. Internal scaling up. We have a hand there. Jane. Mm-hmm.
Hello. I'm working for the city, and I notice how for us it's often when we're dealing with demolition, then this is often, especially in Estonia, I think it's considered some kind of a simple thing to do, and often people don't realize how big this process actually is, and the impact of it, etc. But I also feel like it's an easy solution often to get rid of a building, because it's just if something goes wrong, it's an easier version to get out. In order to become more circular, I feel like this is really like one node which needs to become more complicated. Like, do you agree? Do you think that this process? How is this process in Belgium? Like, do you have regulations about demolitions?
Not yet, but it's coming, I think. No, Christian? Yeah, it's up there. There's not yet any regulation around it. Working with administration, it's also about the person you have in front of you. We're all people. So you have indeed a push toward avoiding it, but it's not regulated. So you can demolish as you wish, let's say. So yeah, I completely agree with you. And to come back to what you mentioned at the beginning, the fact that it's often not done because of, or at least a building is not often kept as such and renovated, and often it's opted to be demolished. It's very often an economical reasoning behind. Renovation is much more costlier because you have more risk, or at least that's what has been told us. So I think there's definitely a mind shift that has to happen there, in which we understand the value of keeping a building, or we value it much higher than demolishing it, rather than taking the risk factor as the main kind of criteria, which is today. It's a risk factor which is done at the financial level. It's a risk factor done at the engineering level. We don't know what concrete quality we have, so therefore we don't work with 2%. We work more with 15%. Therefore more. And so on and so on. For the building in Pauli, for example, at the very beginning, because you could see that it's an existing building, we added quite a big load on the whole perimeter of the facade. The engineers first, they just wanted to extend and pump tons of concrete to add to the foundations, which would have completely made no sense. Then if you do that, it's not good to insulate with rice straw bales, because you put double the amount of concrete in the foundations again. But it has been a negotiation with them, and a long one at the very beginning, to try to determine, but could you lower this, and what if we don't add any other weight inside and we keep everything, and at the end we didn't do any add extra foundations, and it works. And so today it's quite a negotiation, but more and more people are standing at our side, I would say, at least in Belgium or in France, in those contexts, because each region has a different position. But so you feel that the negotiation shrinks from 5 months now to 2 months, but yeah.
Yes, and I feel like in the demolition process, also architects should be involved, like in order to recognize what is valuable, what is not. It's if you want to keep something, but I feel like architects don't really know how to, I don't know, like how to reuse materials, how to gain certificates, etc. Like this process is
Yeah.
You don't study this in the school.
And there comes the importance indeed of sensibilization, training, teaching, because you have to create a larger mass of people aware of these things, and sometimes even aware of the websites. I mean, sometimes it's as simple as that. It's just knowing what the website is, where you can collect all of these things, or the right engineers who are willing to kind of take the adventure with you, and who are aware of alternatives to the basic Excel sheet one uses with concrete. So the things are there, or starting to be there, but the way to them is still very often, it has a high threshold.
Hi, I wanted to ask, it's a little bit off topic, but from that you mentioned that it's important, this sustainability of how you work. And for me, it's interesting that you're a cooperative, and maybe you can talk a little bit from that, like why did you organize in such way, and what does it mean? Because I think it's not that common, at least here.
Yeah. So today, BC Materials is a cooperative, a workers' cooperative. BC Architects, not yet. BC Architects is an architectural company. So BC Materials came after, and was a wish for us to organize as such. What does that mean? That you have, I will not get too technical, but the basics is that the people working for the cooperative, they are, or at least they have the ability, or they're requested to be part and have shares within the cooperative. Those shares give you access to decision-making meetings. They give you access to mostly decision-making. So these are the basics. The cooperative basically means that the company is owned by its workers, or the people working there. Why I said today that we wish to continue that is how we set up the cooperative as such then, there are positive things, but there are also flaws. And we wish to take advantage of this moment of understanding and making that cooperative better, to understand what it could have as influence on BC architects in becoming as well a type of cooperative. So this is the kind of the basics of the idea of a cooperative.
I have a question on the excavated earth, using it. We have a lot of clay here. Probably if I start digging, we get something out of it. What is really stopping me from using it as a material in a building?
You shouldn't ask me. Sometimes also, I mean, yeah, what is stopping us from using it? Well, there's definitely the ones who prescribe the materials are we architects. So there must be a lack of use of these materials by architects, that one. The excavated earth in Tallinn, I suppose it's extracted, disposed. So by the act of disposing it, it becomes a waste. By calling it a waste, it enters a different regulation system, meaning it becomes very hard to use waste in a building. Now I'm assuming, of course, I don't know the Tallinn context, but this mostly is one of the aspects. And also if demolition or excavation is not regularized or is not organized as such that it allows easy access to these disposed materials, meaning that, I don't know, if excavated earth is mixed with debris or demolition of concrete and a bit of glass that has been crushed, if it's all mixed, if it's sieved, compartmentalized, then it's a little process in order to make it easier accessible for construction, contractors, and so on.
Anybody wants to comment on anything? Yeah, there you know.
Another question about the earth, because I've heard that it usually doesn't stand up well in like rainy climates. And I've seen actually a lot of rainy climates use it. So I think there's a lot of rain in Belgium. So I wanted to ask how you've dealt with that.
There's definitely a lot of rain in Belgium. And I think here too. But no, I mean, of course, water, clay plaster as such, or compressed earth blocks as such, without any protection cannot stand like this outside in the rain. So therefore, you have, I would say, very easy kind of ways to work with it. It means you need if you use it outside, use an extended roof. You don't put it straight on the ground. You put it higher. So it all depends. And of course, I would never use actually earth as a facade material. It's not made for it. And so once you understand and learn about the characteristics of a material, you use it wisely. You use it where it can be used, because once I would say you want to use it as a facade material, and then you add cement or lime to protect it more, well, you lose the circularity of it, because you cannot bring it back to its initial resource. So therefore, earth in a kind of unbaked state and a kind of pure state, it's perfect for everything which is interior. And it's also the interior is the part that is refurbished continuously. I mean, we're here now like this. In 10 years, another institution comes here and they're more into black and change everything, take everything down. Therefore, it has logic for the materials interiorly to be used or to be done by something that has a complete circularity effect. Something that is structural, not. So therefore, I think knowing the material allows you to understand what architectural details you have to make or do in order for it to withstand rainy climates, sunny climates.
Thank you.
Thank you. Roland, we have a question.
Thank you for the presentation. A very technical maybe question, but still we have a lot of people maybe are interested in as well. You mentioned that instead of a technical sheet, you're working with a technical protocol. What does that mean?
I went very fast through it. Well, it means basically you're using a bespoke material. So bespoke material, which is in the case of the rammed earth using stone dust. It's coming from a local quarry. We're mixing it on site, and we make a sample. We bring that sample to a lab. We test it. It gives us a megapascal, how much weight it can take, because it's load bearing. If we're on a good track and it reaches that thing, the formula is kind of, okay, this is the formula for the contractor, meaning like 1/3 this, 1/4 that, 2/3 this, and so on and so on. So there you start already to set up a protocol. It's not you go to the contractor and you say, you buy that bag and you make it. You tell him, you take this, you take that, you take this. You mix it in such a way, and then you use it in the construction. Therefore, as this material is mixed on site, there is human error. It could be that somebody forgets once a third, or that something falls on it and the little beer bottle, they forget it and it's in it. So this means that by making the mix, the protocol we set up is that each, I don't remember in that case, let's say 10 mixes, we take one mix out and we keep it aside, and it's tested in the lab in order to make sure that the mix throughout the construction process stays correct. And this is what it means setting a protocol rather than a technical sheet. And luckily, I mean, it's a big thing, because it's the insurance company basically. It's not the insurance company. In France, you have, it's called controlling entity, let's say, which needs to be linked to a construction, to a project. And it says okay or not okay. If something is not okay, the insurance company is not going to pay for it if something happens. So they have to say okay, okay, okay. And so if you have bureau de contrôle, so these controlling entities which are slightly more open-minded, and it's happening, I mean, with a very strict controlling organism, such a building was not possible. It's still kind of in a museum setting, so it's public. So therefore, they allowed and they confirmed, okay, to use a protocol and not give us a technical sheet.
And is that a government appointed office who controls them?
No. The control.
Appointed, but I mean, they are
Yeah.
registered, so
Yeah.
it's equal to government
Yeah.
approval.
Yeah. This is the French setting, of course.
So we will have another chance to ask questions later on also in the panel. It was very inspirational. I think there's a lot to learn, and also in Estonia we're having this renovation marathon right now. I don't think anybody has thought of using straw bale as an insulation material. You have, of course. We should think about scaling it up then. Thank you again.
Okay, thank you.